Yo, yo, yo! This is the Unit 10 review. I like that one. That's the best one.
Yeah, I like that.
Okay. All right, oh gosh, this is Unit 11 review. Shoot. We're not doing it again. Unit 11 review, question number 1. Write an equation for each of the circles. So an equation of a circle is going to look a little something like this. It's going to be in this form. We call this the standard form of a circle. Okay. All right. It'll mean a little bit more to you when you go to Algebra 2 and when you take pre-calc and calculus and all that stuff. So the H and the K do represent the center. So H comma K is our center. And that R is our radius. Alright. So when I look at these circles, I need to know what their centers and radii is. So the circle on the left here, this blue one, looks like it has a center that's right here. And the coordinates of that point are -1, 2, 3, and then up 1, 2, 3. So the coordinates are -3, 3 for the center. To get the radius, I'm going to have to count. So from the center to the circle is a 1, a 2, a 3, a 4, 5, 6 units. So it has a center of 3, 3, and a radius that's 6. So that means my equation is going to look something like x minus -3 squared plus y minus 3 squared equals 6 squared. Now, that's all right, but when I see the minus, I'm going to make that a positive. And instead of leaving it as 6 squared, I'm going to say, hey, 6 squared is 36. So I'll just write 36. So here's my standard form for that equation of a circle. All right. Over here, my center is 0, 0. So center's at 0, 0, and my radius is a 1, a 2, a 3, a 4. So we have a radius of 4. So that means my equation's going to look like x minus 0 squared plus y minus 0 squared equals 4 squared. Now, we're not going to leave it as x minus 0 because that looks silly. So we'll write it as x squared, y squared. And 4 squared is 16. So this is the prettiest version of that. All right, down here it says the center is 0, 0, and the radius is 3. Well, like the last one, because the center is at 0, 0, it's just going to be x squared plus y squared. And the radius is 3, so that would be 3 squared. But we've done a few of these, and now I'm just going to write what 3 squared is. 3 squared is 9. Cool, cool. And then this one over here gives me a center at -2, 3. So it's going to be x minus -2. So I'll write x plus 2 squared plus y minus 3 squared. And that's going to be a -5 squared. And when I have a words is hard. That's a square root of 5 squared. So when I square a square root... Hey, Aiden.
Yes.
What happens when you square a square root?
It goes away.
Yay. It's kind of like remixing a remix. We'll be right back to the original song.
That's good.
Appreciate it. So this should be an x plus 2 squared plus y minus 3 squared equals 5. Over here we're finding the length in meters of this arc. So length tells me that it's a piece of the circumference. So I know it's going to be a 2 pi r kind of thing, because that's the circumference formula. Now it's only 135 degrees out of the full circle, so we'll multiply that by the 135 out of 360. All right. So we're going to multiply that all together, 135 over 360 times 2 pi r. And when I do that, oh shoot, r is 8. The radius here, center to the circle, r is 8. So oops, 8. All right, so when I multiply that all together, punching this in on my calculator, 135 divided by 360 times 2 times 8. So I didn't multiply by pi yet because I'm going to get that exact length first. So when I multiply all of these except for pi, I get 6. So in terms of pi, it's 6 pi. And again, I got that by multiplying 135 out of 360 times 2 times 8. Now multiply by pi. And according to Tim Krashnikan, 6 pi is what? 18 point what?
85.
I got to round it to the 10th. So if it's 18.85, we'll round that to 18.9.
Yeah.
Okay.
If you just said it, you just said the 10th. If it says the 10th, then like, I'll allow it to the 10th.
Sounds good. Thanks, Tim. Up next, we have an archaeological dig. Ooh. Blah, 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 blah. So we found this thing, and it's a quarter of a circle. So quarter of a circle means 90 degrees. And we know that the length of this thing is given as 5.2 centimeters. So in the previous problem, we used our formula for the length of an arc, and we said the length is equal to the degrees out of 360 times 2 times pi times r. Well, in this one, we're going to use the same formula. The length equals the degrees out of 360 times 2 times pi times r. Tim, you still got your calculator ready? All right, be ready. Now, in this one, they give us the length. They tell you, hey, the length is 5.2. So we'll plug that in there. They tell us the degrees is 90 out of 360. And we are trying to figure out what the r is. So the way I'm going to do this is I'm just going to make it look a little bit prettier, all right? I want to clean up all of that. So Tim, on your calculator, can you do 90 divided by 360 for me?
360. That's obviously going to be half.
A fourth, right? Yeah.
I have a fourth. Yeah,
All right, so take that 0.25 and multiply it by 2.
Now that will be a half.
There you go. Now multiply that by pi.
It will be like 1.6 or 1.57.
1.57. Okay, yeah. I'm going to not round this one right away. All right, so Tim just did all the calculations on the calculator for me and got 1.57 after multiplying those things together. So we're going to use a little bit of algebra. We're going to have to solve that for the radius. So Tim, on your calculator, can you do 5.2 divided by that 1.57?
That would be 3.31.
All right, so Tim did the math for us, and he said that the radius is equal to 3.31.
Yeah, what are the units?
It's centimeters. Yeah.
Centimeters, okay.
All right, and then the question wants the centimeters, but rounded to the whole centimeter. So it's closer to 3 centimeters than it is to 4.
Yeah.
So then the sundial has a approximate radius of 3 centimeters. Cool. So the last 2 questions use the circumference. These next 2 will also use circumference.
Oh yeah, I remember those. Those things were fun. Now I'm in like a lot of AP classes.
So we have a measuring wheel. So what we need to do here is we need to figure out the circumference of this. See how much each rotation, how big each rotation is. So again, a rotation is the full circumference of that wheel. And the radius is 6. So C equals 2 times pi times 6, which is 12 pi. Tim, you think you can do 12 pi for me?
Yep.
I'm guessing 37 point something.
Yeah, you're right. 37.7.
Awesome. Thank you, Tim. So keep that in your calculator. So one rotation is about 37.7, and these are inches. But we want a total of 75 revolutions. So one time around this circle will give you a distance of 37.7, but we want 75 times around that circle. So can you multiply it by 75 for us?
It's like, I don't know if this is right or not, but I got 28.27.3.
20. All right, read it off. 28 what?
27.4.
All right, cool. So that's a whole lot of inches.
But being music got converted, like.
But we're going to convert it to feet.
Yeah.
So remember, how many inches are in each foot?
It's like 12.
So we have 12 inches. So we're going to divide by 12. So take that same number and divide it by 12 for us.
Answer will be 235.6.
So it's 234.6.
235.6.
Sorry, 235.6. And we want to round that to the nearest whole foot. So since it has a 0.6 at the end, we are going to round it up to 236 feet. Okay. Cool, cool, cool. So that one dealt with the circumference. This next one does too. We got the track. All right. And if I split the track up right here, you see the shapes. We have a half a circle, a semicircle over here. Another semicircle over here. So if I put those two together, it would make a full circle. And since we're finding the length of the track, that's going to be circumference, the distance around that semicircle, and other semicircle, which makes one circle. So we need the distance around, called the circumference. All right. So that's going to be 2 times pi, and it says our radius is 25. All right, Tim, can you do 2 times pi times 25? I guess that's 50 pi. Can you do 50 pi for us?
Yep. It'll be 157.1.
157.1. And that's meters. Cool, thanks, Tim. Now, that'll get us around the rounded parts of this track. But we also need the straight parts. And according to the sentence, each straight part is 65. So we'll take our roundy parts and we'll add 65 and another 65 because there's 2 straight parts. So can you add 130 to our 157.1?
Yep. And it should be obviously 287.1.
287.1. Awesome. And they wanted it to the whole meter, so we'll call 87.
Yeah.
All right. Last 2 problems here, Tim.
Okay.
All right, so the next one asks about area. So area means filling this space. Woo, 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 woo. All right, so we're going to use the area formula, pi times the radius squared. But we don't want all the area. We want 315 degrees out of the 360 degrees. All right, so in this problem, my radius is 3, so I got 315. All right, Tim, you ready for the calculator? I got 315 divided by 360. Okay, and then I've got times pi. Oh, you know what? We're going to leave it in terms of pi, so don't. Just 315 divided by 360, and then times 9er.
9?
Mm-hmm.
Okay. 7.875.
7.875 pi's. Cool. And now let's get an answer to the 10th place. And that means we're multiplying the pi by the number now.
It'll be like 9. Because you're supposed to round it and then you try to put pi, right?
So we're going to do 7.875 times the pi button.
Oh, okay. Okay, that'll be
24.7. All right. So Tim rounded it to the 10th place for us and got 24.7. It's kind of hard to hear him because he had a chicken sandwich in his mouth.
Yeah.
Or is that a burger?
Burger.
Is that McDonald's?
Burger.
Burger King, man. Classy. All right, and then last up for section A here, we got a golf course sprinkler, making a 225-degree arc. So it's like, so it's about 225 degrees of the whole circle. The worst drawing ever. And the length of the spray, aka the radius, is 14 yards. So even though my picture is awful, I know I want 225 out of 360. And I want to multiply that by pi times 14 squared. So I know 14 squared is 196. So Tim, you ready for some calculator work?
Yep.
Our last one for a while. All right. So I know 14 squared is 196. We got 225 divided by 360. Go ahead and hit times 196. And let me know what you get.
I don't know if you're right or not, but I got 122.5.
122.5?
Yeah.
That sounds about right.
Okay.
Now let's take that number and multiply it by pi so we can get a rounded answer.
It'll be 384.8 because I rounded basically, but it wants a whole again, like whole centimeters.
It doesn't say. It doesn't specify in this problem.
Okay, so it'll be like 384.84.
Okay. All right. So there's part A of the review. I hope it helped. Good luck.